So if everyone can hear me, I think we're just about set to get started here. So welcome to the first of the kind of deep dive mobile track where we're going to talk through kind of the steps of building yourself a mobile application. This is the first one, starts with design. Later today, we're going to carry on through develop, testing and deployment. Intermixed with that, as Ali mentioned, if you didn't see it earlier, we have a couple of additional sessions coming from showing customer use cases. So there's a ton of great stuff we've got in the next couple days on the mobile track. So look forward to seeing people there. I'll introduce myself a bit. My name's Adam Fraser. I'm the architect on Sync Gateway on the mobile team. So kind of handling most of the server backend. Been with Couchbase for a few years now. So today I'm going to walk you through two main aspects of mobile applications. Some basic data modeling. So how are you going to go from a rough idea of an application to, I'll take you through an entry-level data model. And then I'll talk about how Sync Gateway manages security, what you need to do to set up access control for your application. So let's go ahead and get started with the data modeling section. So to make this a little bit more concrete, I'm going to start with I'm going to use an example of a task list application. It's a simple application. The main features, you have a user that can create task lists, can share that task list with other users. The owner is allowed to add and modify tasks to the list. Users can also add and modify tasks. And those tasks, just to add a little bit of complexity, we'll just add some images to those tasks. So your basic application is going to look a little something. You've two basic entities. You've got a task list, you've got a task. Your task has a name and whether the task is complete. Your list has a name, owner, and users. So the first question might be, okay, well, shouldn't there be a user entity in here? Here we're going to be taking advantage of the Sync Gateway user. So you don't need to create a user entity in your document. Sync Gateway has the concept of users and roles, so we're going to leverage that as the owner and the users and the owner and the users for your application. So you've got your basic entities. The first thing you need to do, obviously Couchbase Mobile, similar to Couchbase, is a document database. So you need to turn your entities into objects. So aside from the basic field mappings, which are fairly straightforward here, you're just taking your fields and mapping them directly to objects. You notice that there's an additional field we're adding here called type. I think this is probably the most common data modeling approach. So obviously a document database is schemaless, so you don't need to define your entities. But at the end of the day, if you're building a real application, you need to be able to identify what are your entities, what's your business logic that you're going to be associating with those entities. So a common, straightforward modeling approach is to define a type in each of your documents and drive your business logic off that type. And you'll see as we move through the access control section today, that's what we're going to be doing here. So the next missing piece at this point is the ID for a document. So, in a typical relational system, all of your rows are going to have IDs. The interesting thing about Couchbase Mobile, which is maybe a little bit different than Couchbase Server, is that we need to have the idea of the concept of the ID within the document itself. So once these documents are replicated up to Couchbase Server, then all of your task list documents here, your task documents, what's shown as the ID is just going to be the key in your data store. But when you're working disconnected on Couchbase Lite with a document that hasn't yet been replicated to the server, you don't know what that ID. You need to be able to define what that ID is going to be before it gets pushed up to the server and before it actually has a key. So the way we manage that in Couchbase Mobile is define protected property _ID, which stores the ID property, and that can be defined by the client. The client obviously then is responsible for defining uniqueness on that. If they try and push up an ID that's a duplicate of somebody else's, then you end up with a conflict. But at a high level, from a design perspective, you're going to need to stick IDs on your documents as well. So let's talk a little bit about the relationships we have between documents. In this case, so far we have our task list and we have our task. Each task list can be associated with multiple tasks. It's a standard one-to-many relationship here, so you stick the task list ID on the task itself, and that's defining your relationship between the task list and the task. You see also we have a many-to-many relationship here between the task list and the user, And we're storing that as an embedded array initially. So on the task list itself, we have a collection of users. A user can be associated with many task lists. But immediately that's going to pose a few problems for us. So let's look a little bit closer at what's actually going on with this application when we're working with other users. So within the application, you have the concept of, for your given task list, you can choose who else you want to see it. So here I am as myself, Adam, and I've got a few users that I want to add to this list. So Bob and Alice, I'm adding to my list for sharing here. And so embedding the list members in the list document, we're already running into problems with that approach. And I'll kind of cover 3 problems here that you want to think about. So the first would be document size. When I've only got a couple of users in this document, it's not a big deal. The user property is just an array of a couple of entries. But as soon as you start to have, if I'm very popular or really want to share my tasks around, I could have hundreds or thousands of users within this. All of a sudden, the size of your list document is bloating. And that list document is going to need to get shared with everyone I'm sharing it with. So all of a sudden, you're pushing all this user data around to every other user. The other issue then becomes around document volatility. If every time I add a new user to my task list, I need to do an update to this document to add them to this array, then again, that's an update to that document that needs to get pushed out to everyone who has visibility to that document. And then the final issue is a functional issue for our particular app, which is privacy. In our application, we don't want other users who I've shared the list with to know who else I've shared it with. So in this case, if I want to share the list with Dan, I don't necessarily want Dan to know that I've also shared the list with Tron. And so we have to share the list document with users because that's how those users see what the list is, see what the list's name is. So we need to move the users out of this document if we want to, we need to move the users out of this document if we want to preserve that privacy. So what we'll end up needing to do is to create a new entity to manage that. So we'll create a task list user entity. It's going to have its own document format. Again, as before, we have the type defined, which defines what type of document it is. Here we have the username, which is who it's getting shared with, and the reference back to the list itself. So we've got the task list ID, and we also add the task list owner in there. So at this point, we've got our task list and task list users split out. So let's go back and revisit tasks for a minute and talk about the one piece which was missed earlier, is that we want the ability to add an image to the task. Within Couchbase Mobile, adding attachments is really straightforward. There's, again, another protected property called underscore attachments, which stores your attachment data. It's any blob data. In this case, we've got an image. I've kind of glossing over a bit of the details here, but in that image definition is going to be the image type, the image digest, information on basically a reference to the attachment body itself. One of the reasons I can gloss over it here is because Couchbase Mobile is really doing all the work for you here. So if you're using the attachment API in Couchbase Lite, you're really just passing it a blob, and it's doing all the work to build this attachment, build this custom attachment property within the document itself and replicate that up to Couchbase, to Sync Gateway and then to Couchbase Server. So at this point, we've got kind of the core functionality of our app. We've got our tasks, we've got our task lists, and we've got our task list users. One additional piece of functionality we want to add is we would like the ability for moderators to be able to review at a sort of administrative level all of the task lists and tasks in the system. And one option would be we could just define these moderator users out of the box and seed them. But we want the ability to basically add and remove moderators over time. And we're going to use a moderator document to do that, to identify which users have moderator privileges. Now, there's a couple of approaches you could do here. I mean, instead of defining a moderator document, you could give everyone a user profile document. And on that user profile document, you could set a flag to say, is this person a moderator or not? But again, you always want to be thinking about, am I creating data that I need? Am I creating data that I don't need? And so in this case, at this stage in our application, it's only moderators that we care about their user profile. We don't have any user profile information we're storing for anybody else. So there's no need to create a lot of documents that we don't need to use and have those documents be getting replicated around. So instead, we'll only just we'll create a new type of document called moderator and really just stick the username on that. So at that point, we've got kind of our full data model for our simple task list application. So going back to the entity model, we've got task list, task list user, and moderator. And we've got relationships between those based on the task list ID and relationships between those based on the users. And so we've talked about how that turns into documents. We've got four types defined. We've got task list, task list user, task, and moderator. So that's really the kind of bare building blocks of our application. From this, you could go ahead and build your disconnected application. So you can go to Couchbase Lite, work with Couchbase Lite strictly locally, and if you're building an offline application, you're done. It's just a matter of building out the UI around this data model. Now, I think the obvious question is that with an application like this, we don't want it to be offline only. We need it to be connected. We need your tasks to be shared with everyone you've granted access to. But we have very specific rules about how we want people to access that data. And so the kind of next key step in your design is talking about access control. And so when we're talking about access control, so when I was just talking about building an application that is strictly offline, that's your circle on the left. So you could build, with what we've done so far, you can go ahead and build out your task list application as a disconnected application, kind of prove out the general flows. But now you need to think about, okay, how's that data going to get replicated? And so Ali in the previous talk outlined the role of Sync Gateway. So Sync Gateway is basically the intermediary between Couchbase Lite and Couchbase Server. It manages replication of data. It manages data security. It provides a variety of other APIs, which I won't get into in this talk, but it provides kind of streaming APIs, batch APIs, which could be used by things other than just Couchbase Lite. But for the purposes of this discussion, it's what's providing our replication API. So documents are getting written through Sync Gateway to Couchbase Server, and documents are getting read back through Sync Gateway to Couchbase Lite. So when we're talking about access control, we're really talking about three main groups. We're talking about read access and routing. So basically, who can read the document, and when does that document get replicated to their device? We're talking about write access, which is who's allowed to write a particular document. And we're talking about data validation. So data validation is basically where you're implementing your business logic. So for a particular document type, what are the requirements for that document? Is this document valid? Is this document, are the changes being made to this document valid? So let's start talking a little bit about read access. And to understand read access and how Sync Gateway models read access, the first thing you really need to talk about is our channels. And so within Sync Gateway, all documents can be assigned to channels. And channels are really just a lightweight idea. They're really just tags associated with a document. And it's just a way to group your document into functional areas, really. So your documents get assigned to channels, and then your users and roles also get access to those channels. So there's two ways for users and roles to get access to channels. They can get a static access grant. So your admin can say, user one, you have access to this channel. Or documents can do a dynamic access grant and give user one access to a channel based on the content of the document itself. And at the end of the day, it's channels that are going to define what documents users can read. So let's just kind of run through a quick example here. So we've got 3 documents over on the left, document 1, 2, and 3. We've got 3 channels, a couple of users, and a couple of roles. So let's assign some channels to the documents. So a couple in channel 1, a couple in channel 2, one in channel 1, and one in channel 3. So the documents end up in those channels. Now at this point, the documents are in channels, but the users have no visibility to those channels, so the users aren't seeing any documents. So we'll grant channel access to a few users and to a few roles, and we'll go ahead and give role access to one of the users as well. And at that point, now that they have channel access, those users can see the documents that are in those channels. So user 1 who has access to channel 1 gets document 1. User 2 who has access to channel 1, but also has access to channel 3 through role 2, gets document 1 and 3. At a conceptual level, there's not really much more to channels than that. It's basically a way for you to define a named space for your documents and access to that named space for users and groups. But within that model, there's a huge amount of flexibility as far as the security model that you're defining, I think. And you'll see that in a little more detail as I talk about how people get granted access to channels in the first place. But the concept itself, I think, is fairly straightforward. So it kind of leads to the next question, which is, how do you assign documents to channels in the first place? So the answer to that is the sync function, which is kind of at the core of Sync Gateway's inbound data replication. So the sync function is just a JavaScript function that is run every time a document is written to Sync Gateway and does two main bits of work related to channels. It's assigning documents to channels, and it's defining access grants for users and roles to channels. And I'll go through all of these in a little bit more detail with our task list application to kind of walk you through exactly the details. But at a high level, the piece to understand is that on every write, the sync function gets executed, and based on that, it's defining your access control for that document. So the sync function is just a JavaScript method that takes only two arguments, the doc and old doc, where doc is the incoming new version of the doc, and old doc is the previous version of the doc. And one critical piece here is that the sync function operations are based only on the document itself. So it can't be referencing other documents in the system. So any decisions it makes about access control, about channeling, about write access, are all based on the document itself. That's important in a distributed system like Couchbase Mobile, where you have multiple users writing the document, updating documents concurrently. You can't be relying on the database state elsewhere other than the document itself. The document itself is the only atomic transaction you have at the time, so that's why it's critical that you're writing your sync function depending only on the document contents. So let's talk about routing first. So basically, how do you get a document into channels? Excuse me. Within the sync function, you have the function called channel. It's as simple as that. You say channel, you provide a list of strings for the channel names, and that's going to assign the document to the specified channels. So let's go back to our task list application. And what we're going to want to do is create a channel for each task list. So you can see the sync function in the middle. It's checking our doc type. So like I was saying, we use our document type to identify our business logic. So just a reminder, this is what our task list looked like. So we're saying if the document type is task list, then we're going to want to channel that to a channel called tasklist.id. So we're using, we're using the task list ID to define uniqueness for this document. What you choose to use for uniqueness is up to you. If your business logic can guarantee things like the combination of owner and task name is unique, then you could use owner and task name as your channel list. I think for simplicity, I think what people tend to do first is just to generate a UID and use that to guarantee uniqueness across all documents. So that's what we'll do here, but we're not strictly enforcing that. That's just a design decision. So as a result of executing the sync function against this document, you're going to get this document assigned to channel tasklist.UID. So now we've got the document in the channel, but now we need to we still don't have anybody else with access to that channel. So we've got channel tasklist.UID with this document in it, but that's all we've got so far. So now we need to be able to grant access to people for our new channel. So the function to grant access is just called access. You provide one or more names, and then one or more channel names, and so that will grant the given name access to that channel. So let's go back to our task list again, and let's kind of iterate on our sync function a little bit. so that in addition to creating the channel, we're also granting the owner access to that channel. So our results from that, in addition to the doc being assigned to the channel, we've also got that user getting access to the channel as well. So now we've got read access defined, but we need to think about write access. We don't want just anyone to be able to write documents or write task lists. And so there's three main built-in functions that you can use in the sync function to define write access. We've got require user, which is going to reject the update if the active user isn't the user provided. We've got require role, works similarly except for roles. And we've got require access, which is going to reject the document if the user doesn't have access to the channel stated. So let's go and look at our task list document. So for our task list document, the only person we want to be able to modify this document is the owner. Remember, the tasks, which can get added by other users, are actually being stored as their own document. So for the list itself, we only want the user to be able, the owner to be able to change it. So we'll add some write security to say only the user is allowed to modify this document. And then finally, let's do some data validation. So data validation really just allows you to construct your business logic in JavaScript and then define, throw an error and reject the document if your validation fails. So here we'll do data validation for type enforcement, and then we'll do some data validation by type. So let's say for the task list document, we want to ensure that the name is present. So we'll just add some basic functionality to look for the name and to reject the document if the name isn't present. So at this point, we've got the kind of outline of what our data security is going to look like for the task list document. So we can spend some time going through and having a look at what that would look like for a few other types of our documents in the system. So we've got our task documents, which are coming through. So we're going to add another block in our sync function to check for task documents. We want to channel those documents to the task list. So task lists and their tasks are going to be going to the same channel. In order to add something to the list, we want to be sure that you have access to the list. And the way we're going to validate that you have access to write to that list is doing a require access call. So if you have access to that task list's channel, then you have access to write these task docs. So right now, based on what we just went through for the task document, or the task list document, the only person who has this write access is the owner of the list. And so we need to fix that, and obviously that's going to be part of our task list user doc. So we'll add a new block to the sync function for task list users. Within that, we'll grant access to the user who's getting the grant, and we'll give them back to the task list document. And then we'll also require user being the doc task list owner, because if we're adding task list users, the only person we want to be able to do that is the owner. Now, one interesting piece here is that we don't want to stick the task list user document into the task list channel. For the reason we talked about earlier, we don't want everyone to see that document. And so we're going to create a new channel called tasklist.uid.users, or .id.users, that's going to store all these documents. And so, pardon me. So if you've created this channel, you've stuck this document into this channel, but you need to give someone access to this channel, otherwise there's going to be no visibility to these user documents. So you could do that by granting access to the owner here to this new users channel. The problem with that approach is that every user that comes through is going to be reapplying that grant to the owner, because the owner is always going to be the same for the task list. So it actually makes more sense for us to go back and modify our task list document to go and create that users channel when the task list gets created, and then just have the task list user document channeling documents to that channel. So that kind of reinforces one point, which is that the channel doesn't need to exist per se or have any documents in it when you're granting people access to it. So there's no ordering required here. There's no initial setup for channels. Basically, as soon as you assign a document to a channel, or as soon as you assign a user to a channel, the concept of that channel gets created, and at that point, any kind of future intersection between documents and users will get replicated. So let's just cover the last item that we had in this, which was the moderator type. So on the moderator type, we're going to require a new role that only administrators can create moderators. And then we're going to create a new channel called moderators, and we're going to grant this username access to that moderator's channel. And then we'll go back and add every other type of document that we've seen in the system to that moderator's channel so that they end up having visibility to everything, which is our goal. Now that we've kind of completed our 4 task types, we want to make sure that there doesn't result in being a lot of garbage data in the system. So we want to make sure that we're rejecting any documents that don't match one of our expected types. So if anything else comes in with a different type, we're just going to reject it. So at a high level, we've kind of built out our data model now, and we've built out our access control for the task list document. So let's just kind of have a quick look at what this might look like in practice. We have user 1 and user 2. They're both running with disconnected applications. Let's say both of them connect to Sync Gateway. Let's say they're running both push and pull replications. So they're constantly pushing data, pulling data. They're going to be sending data through our sync function. Initially here, we don't have any channels, and we've got our 2 users defined. So user 1 is going to create a task document, a task list document. That document is going to trigger the task, when they push that to Sync Gateway, it's going to trigger the task list functionality in the sync function. That's going to channel that document to task list A. So at that point, our new task list is created. It just has the one document in it. It also, our sync function for task list also does the channel grant. So now we've got 2 new channel grants being added to task list A and task list A users, which, as I mentioned, creates this instance of a channel for task list A users, which currently doesn't have any documents in it. So user 1 then goes ahead and creates a couple of task documents. Those task documents get pushed up through the system. In the sync function, they get channeled through to task list A. So now the user is working on their own. They've got their own task. They're replicating that task only with themselves. So they want to add user 2. So they add a task list user document for user 2. That comes through, gets channeled to the task list users channel, and also grants access to user 2 to task list A. And at that point, user 2 gets access to the task list and the 2 task list documents. So it's skipped ahead here, and user 2 now has gone ahead and created a task for that list. They push that through. It comes through as a task, gets routed to task list A, and then gets replicated back to user 1. So that's kind of the high-level flow of the application. At this point, you've just got a system of channels which dictates what different users can see. The users and roles get access to those channels. You've got your sync function defining your business logic and how user access is managed and how channels are managed. So at a high level, that's really, you've taken your kind of first steps to defining your application at this point. You've got your basic data model. You've got your basic security model. And at that point, you can jump right into developing. And I think the next section, the next talk later today is going to be, right after this one, is going to be taking this sample application and showing you how you can take this and put it into practice. So talking about next steps, the first link there, developer.couchbase.com, mobile training. This training site follows the same path as the talks today. So it takes you through from design to development to testing and deployment. And so yeah, you can reference that site, and it'll cover some of the same material I just covered today. Also, the application that I showed today And the application that's used in the training is available on GitHub. It's the Mobile Training To Do app. If you have a look in there, you can kind of see the details of a real-world sync function. There's a lot more to it than what I've showed today. I've kind of tried to show the kind of very high-level version of it. But yeah, so I wanted to leave a decent amount of time for questions and kind of drill into some of the more specific use cases. Yeah, so why don't we do that now? Sure. I think.
So is user two allowed to change the task list document here?
No, because we have you remember in the actual sync function for the task list, we have a require user on the owner field of the task list, and so.
So what happens if he tries to change?
Oh, sorry. So the question is, what happens if user 2 tries to change the document? Their change to the document is going to get rejected, so it's not going to get pushed to the system.
But that revision owner is user 2, right? If we go back to the sync function, you had used doc.
No.
Should it be old doc?
If you look at so what I've shown here today is a relatively simplified version of the sync function. If you have a look on the GitHub site, you can see the full detailed version. But yeah, there's an additional criteria that you would use in the sync function for the task list document, which would be to validate that owner isn't changed. So on a create, the only person allowed to create a document is the owner. And then on subsequent updates, you enforce that the owner can't be changed by ensuring that the old doc owner is equal to the current owner.
So that's another subsection in the sync function you are saying?
That's right.
Okay.
Oh.
So can a web application talk to Sync Gateway? Is there
Yes,
any
by all means, by all means. So, I mean, what I've got here, when I've got user 1 client app and user 2 client app, user 2 could equally be a web application talking to Sync Gateway's REST API.
So what does it use for the database? There is no embedded database. Does it use a browser database?
You have a few options. I mean, you can build a web application that's a connected application. So if you're building a web application, it doesn't necessarily need to do replication, right? You can use the REST API and build a connected application against Sync Gateway's REST API. And so I think that's the most common use case. But there's definitely a use case to use embedded browser databases like PouchDB would probably be the most common example. PouchDB can replicate through Sync Gateway, and you can use an embedded database that way. But I think, yeah, you have options.
So they store in like local storage or something? Like the browser?
Yeah, I mean, I don't want to drill too much into PouchDB because I'm not an expert on that. But if you're looking for an embedded browser database, you could go take a look at PouchDB.
Okay.
I think the more common use case I've seen for our customers is build a disconnected application on the mobile device with Couchbase Lite, and then build a connected web application that's just talking directly to Sync Gateway through the REST API. So it's more of a traditional connected web app.
It's a connected one. Okay, thanks.
Sure. Oh, sorry, I think at the back was next.
So if I have 2 channels and the rules wind up putting a document into channel A, but I later change that document in a way such that it now no longer applies to channel A, but now applies to channel B.
Right.
Does channel B see it, and does channel A get something like a tombstone?
Channel A doesn't get a tombstone per se, but Channel A will get kind of, users who have visibility to Channel A will get a removal notification. So they'll get notified that that document's been removed from that channel, and then it'll show up in Channel B. So that's a key point, which maybe I didn't cover enough, which is the channels and the access grants associated with a document are only associated with the current revision of a document. So as that document changes, the document's moving in and out of channels, and its access grants are getting granted or revoked. Any other question?
I was wondering if you use the peer-to-peer, I'm sorry, do you need to change this?
So the sync function is only runs on Sync Gateway and enforces your data access as data goes into your backend server. So If you're replicating peer-to-peer, you're still replicating data between devices, but how the security rules are enforced for peer-to-peer replication is within the scope of your application itself. When any of those peer-to-peer devices replicate up through Sync Gateway, then yeah, all of your security is enforced, but your security is really enforcing security in your backend data system.
So what JavaScript virtual machine is the Sync Gateway running?
It's running Auto.
It's running what?
Auto.
Okay.
Yeah.
So and is that
Autos
just
is-
a custom?
I mean, it's a fairly common JavaScript parser and translator. There's a handful of the kind of standard JavaScript functionality in there, like underscore, but
Okay.
what did you have a specific question about?
Yeah,
functionality?
yeah. What I'm getting at is I guess I'm curious why I'm not trying to be critical, but why it's a Go app. If you're going to have all this business logic in here, it seems like if I was able to require an NPM validation module, for example, to do all the validation, that would be ideal. And I'm guessing I'm trying to get at is that intentional for performance reasons or just not the way it's architectured?
I think the main motivation is ease of design and to make designing your sync function as straightforward as possible. We've talked about potential optimizations about having something that looks more like you design your sync function and then you compile it down to something that performs more efficiently. At this point, sync function execution isn't typically a bottleneck for replication. So
all of my business logic then needs to sit on the device, or I would need to set up maybe a separate microservice server that's also syncing with the Sync Gateway that does manipulation on the documents if I want to do
if you're talking
higher
about
validation and more business logic.
if you want to do more kind of integration type processing, where as a document gets written, you want to go out to some external system
Yeah.
and validate that document or trigger some business processes based on that. The typical integration point for that is kind of what we call the changes worker pattern. So your external application is going to listen to a stream that's coming from documents that are written to Sync Gateway, work that stream, and then trigger the appropriate events of that
Okay,
point.
yeah, that's what I meant by a set of
Yeah.
microservices that are watching the
Right.
channels. Okay.
I have two questions. So let's say if I have 20 data types in my document types in my bucket, then I have to define a sync function for each document type.
Single sync function, different blocks within your sync function to process each document type. That's right.
Okay. So from performance point of view, is it worth defining having one sync function and having different sync blocks for each document type, or shall I have different sync functions for
Well, I mean, for a given Sync Gateway database, you have a single sync function.
sync function?
Right.
Okay.
You do want to think about when you're crafting your sync function to minimize the amount of work you're doing that's not necessary. So things like if you have some basic validation that you want to apply to all documents and you want to reject documents if they don't meet that classification, then yeah, obviously do that up front of your sync function and just kick things out right away before you do any more work if they don't meet that criteria. But again, the general kind of type breakdown like we've got in the slide here kind of is an effort to do that, right? So it's the only logic that you're really executing is based on what your type is. You're not doing a lot of redundant processing. But yeah, I mean, when you're writing your sync function, you want to think about the path through and make sure you're not doing a bunch of redundant work, like you're not doing a bunch of checks of things that you don't actually care about. Yeah.
And so my second question is, with a sync gateway, how many devices I can connect with a given?
As far as how you can scale your sync gateway, I mean, there's a lot of different factors that come into that, including kind of like write throughput, read throughput, the number of channels, the number of, the size of your nodes. I mean, I think our standard performance tests have, I think about 10,000 users connected per node, and those users are kind of pushing through, several thousand docs per second sort of thing. But as you can add sync gateways to add to the capacity of the kind of throughput capacity. But a lot of it, I mean, it really depends on your use case. It depends on your kind of a read load, I think it can get scaled out a lot higher with just Sync Gateway. With write load, you need to think about adding additional nodes.
Additional. And a follow-up question to the previous somebody asked from the back. Let's say if I want to use Sync Gateway with my web browser, right? So do you have some APIs called webhooks or something which is?
We have webhooks, but that is actually something else. You wouldn't use webhooks to build yourself a connected application, but you would use webhooks kind of as an alternative to building a changes worker, which we talked about earlier. So
Yeah.
if you're an external system and you want to be monitoring the state of Sync Gateway and acting on triggers based on as documents come through, one way of doing that would be webhooks. So you can register a webhook with Sync Gateway, and when a certain document certain document types come through, you're triggering an HTTP call out to some external system. That's kind of the most lightweight way of doing it. I think for a tighter integration, you would probably be listening to the mutation stream from Sync Gateway and acting on that mutation stream.
Thank you.
This problem might be stretching the bounds of what this this segment is meant for, but in the case where you've got an application that's both client-side, like Couchbase Lite clients, and then you've also got server-side components, maybe that want to use Nickel, for instance, to run queries, to do updates, deletes, inserts, etc. Right now, the only option I'm aware of is using shadow buckets, which effectively creates a duplicate of all of the data without the metadata that Sync Gateway has, and then it automatically keeps them up to date. Is there any plan to have a more integrated way to
So I'll kind
manage
of talk to that in two pieces. I mean, first, it's correct to say that any documents that, if you're working with Couchbase Lite and Couchbase Mobile, any documents that you're inserting into the system need to go through Sync Gateway. And to support something that wants to do something like writing through Nickel, reading through Nickel is fine, but if you want to do something like writing through Nickel, then yeah, you have to use bucket shadowing today. But I think if you go to Jens's talk tomorrow about Couchbase Lite 2.0, he might touch on this a little bit, but we've been working a lot recently on a convergence project that will basically provide an alternative to bucket shadowing and let people use a single bucket to be able to work with Nickel directly against that bucket, but also Couchbase Lite. It's still a little ways out on the roadmap, but we're working hard on it.
On the REST side, tell me about the enforcement of read access on the REST API?
Yeah, it's at the end of the day, replication really isn't anything magic with Couchbase Lite. Replication is just hitting the REST API the same way a connected client would. So your security for read access through the REST API is identical to replication. So any request for a document, it's going to check whether the authenticated user has channel access to that document.
So it's looking at the channels, but it doesn't run the sync function for read
Not
access.
on a read.
Yeah.
So the sync function is strictly write time. Yeah. Any other questions? Sure.
I'll throw another one your way. So the built-in user access, the access controls built into Sync Gateway, make it possible to query the data for Couchbase Lite. But again, say Nickel, if you want to use Nickel, now all of a sudden you have to build your own access control layer, right? Because you can't access Nickel queries through Sync Gateway, for instance.
Right. Are you talking Nickel strictly for read in that case and enforcing read access control, or both, I guess?
Both, I think.
Okay. So again, I mean, a kind of tight integration with Nickel is kind of further out on the roadmap for us still. But even today, I mean, if you're writing Nickel against Sync Gateway's backing bucket, the channel metadata is not anything magical. It's just being stored as a property on the document at the end of the day. So you could write your own nickel query that, adds an additional channel check to verify that, basically filter your nickel results based on channels.
Okay, so there's not necessarily a concrete plan to add, say, nickel query support to the sync gateway API.
There is actually. I mean,
okay.
adding nickel support, like I said, it's on the roadmap, but it's not, we don't have a firm release date for it at this point. I think read would come first. So basically applying read-side security to a pass-through nickel query, similar to what we do today for pass-through view queries. So basically adding a channel wrapper to your nickel query and enforcing channel access based on the user. So we've done some initial prototyping of that already, so I think that's relatively close. The more challenging case is nickel trying to do writes. I think that's probably, to be honest, quite a bit further out at this point.
Okay, thank you.
Anyone else? Okay, I think we're done. Thanks very much, everyone.